Hi everyone. Today our topic of discussion will be periodic table. So here is the periodic table. First of all, you can see that there are vertical columns. These are vertical columns. So how many vertical columns would be there? One, okay, there is two, there is three, 4, 5, 6, 7, and 8. So these vertical columns, they are basically called as groups. They are called as groups. And what does these groups basically represents? They represents the number of electrons present in the outermost shell. So they represents number of electron present in outermost shell. Outermost shell. Okay. Okay. So now there are horizontal rows as well. Like first of all, this is a horizontal row. This is also a horizontal row. This is also a horizontal row. This is also a horizontal row. Yes. So how many horizontal rows are there? One. Then we have two, three, 4, 5, 6, 7. So there are 7 horizontal rows which are called as periods. They are called as periods. Okay. And these periods represents the total number of electron shells. They represent the total number of electron shells. So how many periods are there? There are 7 periods and there are 8 groups. Okay. So first of all, group 1 and group 2, they are metals. Even group 3 are also metals. Okay. But there are some of the elements which are here. You can see with blue color. They are basically called as metalloids. They are called as metalloids. No, no. Okay, so they are basically called as, these elements are called as metalloids. What does basically metalloids mean? Metalloid means these are metalloids. And what actually metalloids mean? Metalloids mean the elements which possess both the properties of metal and non-metals. Okay. So they possess both the properties of metal and non-metal. So on the right hand side of metalloids, like these or other elements, they are basically non-metals. And on the left hand side, D represents the metal. Okay, these are metals. What are the elements which are present between group 2 and group 3? So they represents transition metals. They represent transition metals. Okay, they are transition metals. Okay, they have like some, you can say, unique properties of metals. Okay, so transition metals possess the unique properties of metals. So this is all about the periodic table. There are elements which are present below, but they are not the part of our course. Okay, so let's discuss the periodic table in detail. Okay, so let's discuss the periodic table in more detail. First of all, we have learned this thing that group number, like we know there are 8 groups. There are 8 groups. So group number basically represents the number of electron present in outermost shell. Okay, there are total 8 groups. There are total 8 groups. Okay, so what about the period number? Period number represents total number of electron shells. Electron shells. Okay, so let's talk about them in more detail. Uh, it represents a total number of electron shells, and there are 7 periods in periodic table. In periodic table. Now, if we move from, let's come back to it. If we move from left to right, then you can see that on the left hand side, there are basically metals, and on the right hand side, there are non-metals. So what happens, as we know, non-metals are present on the right hand side. So what happens as we move from left to right, as we move from left to right, okay, as we move from left to right, left to right, non-metallic character increases. Non-metallic character increases. Why? Because we know that non-metals are present on the right hand side and metals are present on the left hand side. So as we move from left to right, non-metallic character increases. And we know that metals are present on the left hand side. So as we move from right to left, as we move from right to left, so what happens? Metallic character increases. Metallic character increases. Okay. This is very important thing because they often ask this thing in exam as well. Okay. So let's move further towards more details of the elements that are present in the periodic table. So first of all, let's start discussing about group 1 elements. Okay. So first of all, group 1 metals, they are basically called as alkali metals. They are called as alkali metals. Okay, as we know that group number represents the number of electrons present in outermost shell. So alkali metals they all have one electron. They all have one electron present in outermost shell, present in outermost shell. Okay, and they are considered to be the most reactive one. They are considered to be most reactive one. We can see that hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they belong from group 1. Although hydrogen is only one which is a non-metal here. Okay. Actually, there is no other place which is suitable for hydrogen in the periodic table. So hydrogen is named to be basically a non-metal which is also present in group 1. Okay, they are most reactive one. What is the reason for that? The reason for that is that it only needs to lose one electron from its outermost shell. Okay, so it would become easier for group 1 metals that they can lose electron easily. Okay, so in order to convert into a positively charged ion, okay, because we know it has only one electron, so electrostatic electrostatic force of attraction is less. Force of attraction is less. You know, electrostatic force of attraction is basically the force of attraction between nucleus and the outermost electron. So electrostatic force of attraction is less in group 1 metals. In group 1 metal. Okay. So, and what happens down the group? Down the group, important thing, down the group, basically down the group, the size of mm, elements increases. Element increases. So what happens if their size is increased, then electrostatic force of attraction decreases. Electrostatic force of attraction decreases. Attraction decreases. So if electrostatic force of attraction decreases, then what happen? It would become easier. It would become easier for them to lose electron. Easier for them to lose electron. Okay. And that is why we can say reactivity increases downwards. Reactivity increases downward. Increases down. Okay. So there are some of the unique properties. So now we have properties of alkali metals. Of alkali metals. So far, we have discussed that their reactivity increases downwards. Okay. And what happens? Their reactivity increase. Why their reactivity increase? Because of decrease in electrostatic force of attraction down the group as the size of basically elements increases. Like you can see, this is basically their size, and that starts to increase downward. So force of attraction between nucleus, which has positively charged proton and electron, that is this force of attraction is basically electrostatic force of attraction. Okay. And as the sizes increase, electron is going far from the nucleus. So what happens? Electrostatic force of attraction decreases and ability to lose electron that increases. So because of that, we can say reactivity increases down the group. So alkali metals, they have some unique properties that only these metals have, and they have some common properties. What are unique properties? That they are soft and they can be cut with a knife. Second is that they have low melting point and boiling point. And boiling point, okay? Boiling point. What are other properties? That they have low density. They have low density, that they can even float on water, can even float on water. So these are some unique properties associated with them. And what are the common properties? Like good conductor of electricity, They are shiny. Okay. So these are some properties. And now let's discuss about some of the trends in alkali metals. Very important trends. First of all, they are also asked in the exam. So that is why I just want to, like, okay, use this one. Mm. Okay. So trend is that first of all, reactivity increases downward. Reactivity increases downward. We have discussed this. The reason for that increases downward. Simple thing. Second thing is that very important. Their melting point and boiling point decreases downward. Decreases downward. Okay. Then we have their density. Their density also increases downward. Okay. So these are some uh, trends which are present in alkali metals. So let's move further towards some of the chemical properties of alkali metals. And the chemical properties are that they react violently with water, violently with water. Okay. They catches fire and burning with characteristics flame and burning with characteristics flame. So they give a characteristic flame color. Characteristic flame color. Okay. First of all, let's discuss about their colors, which are very important. Lithium gives lithium gives red color, while sodium gives yellow color flame. And then we have potassium, and that gives lilac color, or you can say purple color flame. Okay. So these are the flame color that are also tested frequently in the exam as well. So you must need to remember at least their color. Okay. So they react. The second property is that they react with water, and they would forming alkali. Okay, they are in solid state. This is in liquid, so they would be forming lithium hydroxide, which is in aqueous form with the release of hydrogen gas. Okay, so we have to balance it like this. Now it is balanced. Okay, and how hydrogen is tested in it? It is tested with when lighted flame is put into the gas jar, is put in gas jar, then it would extinguish with a pop sound. It would extinguish with pop sound. Okay, so this is what actually happens here. Now let's move towards group 7 elements. Group 7 elements, they are basically called to be as halogen. Okay. And remember one thing, first of all, what are these elements? These are, you can see, fluorine, chlorine, bromine, iodine, astatine. Okay. This, we actually don't discuss this one. So we have fluorine, we have chlorine, we have bromine, we have iodine, okay, then we have astatine. So they always exist in diatomic form. Okay, they always exist in diatomic form. What are basically diatomic elements? Because this is also asked in exam. Diatomic form, very, very important. Okay, this definition is always asked for one number, and they say when two atoms are covalently bonded, are covalently bonded to form one single molecule, to form one single molecule that is called as diatomic. That is called as diatomic. Okay. So now what happens in group 7 elements that they are also called as diatomic? We need to remember their colors, which are very important. We need to remember their states as well. So let's discuss about their colors. Okay, fluorine, which is having pale yellow color. Okay, pale yellow. Chlorine is having greenish yellow. Okay. Then we have uh, bromine, we have reddish brown color. Then we have grayish black. And then we have black color. Okay. Let's discuss about their states as well. Fluorine exists as gas. Chlorine also exists as gas. And now bromine that exists in liquid state. Iodine exists as grayish black liquid, grayish black. And astatine exists as black color. Okay, astatine exists as black color. Okay, so let's move further. There are some trends that we want to discuss here. Trends is that we can see that states are basically changing from sorry, I've just written grayish black here, but it is also basically a, you can say, is in solid state. We have to discuss its states here, and that is also basically in solid state. So we can see here that basically elements are changing from gas to solid state. So we can say that melting point and boiling point increases down the group, increases down the group. Okay. Then we have reactivity, very important thing in halogens. That reactivity, like for example, we have discussed about group 1 elements, their reactivity increases downward. But here, reactivity decreases downward. And what is the reason for that? I just want to explain this thing. We know that size, fluorine, chlorine, bromine, iodine, astatine, first of all, their reactivity depends on reactivity depends on ability to gain electron. Ability to gain electron. Why? Because they have 7 electrons in their outermost shell. Ability to gain electron. Why? Because they have 7 electrons in their outermost shell, so they need only 1 electron to complete their outermost shell. So what happens as they go down the group? Size increases. Size increases, then what happens? Electrostatic force of attraction decreases. Electrostatic force of attraction, which is basically the pull of electron towards nucleus, that decreases. If that decrease, then what happen? Reactivity also decrease downwards. Okay, because reactivity depend ability to gain electron, and if the nucleus would not be able to hold that electron, then what happens? Reactivity decrease downwards. Okay, but here we want to discuss about some of the properties of these halogens. Now, what are those? Because this is very important thing that we have discussed here, that reactivity decreases downwards. Now we are going to use this one in their application. For example, if we are reacting chlorine, okay, chlorine gas is basically bubbled through, you can say potassium bromide. This is potassium bromide. So what happens, as we know that chlorine is up in the group. So we know that bromine is downwards. So chlorine must be more reactive than bromine because chlorine is upwards. Okay. So what happens? It would displace the bromine and would be forming KCl plus Br2. As chlorine is more reactive than bromine, that is why it has displaced bromine. Okay, so now we are going to balance it like this. Let's discuss about their states. Gas, that is in aqueous form because chlorine exists as gas. So aqueous form, and this bromine is basically in liquid form. Okay. So now let's take some more examples. Cl2 that basically reacts with Ki. We know chlorine is up in the group. Chlorine is more reactive than iodine, so it would displace it. KCl plus I2 would be formed. Okay, this would be in solid state because iodine exists in solid state. This would be in aqueous form. This would be also in aqueous form, and this would be in gaseous form. Okay. But now, what happens when bromine reacts with potassium chloride? When bromine reacts with potassium chloride, bromine is down in the group, so it would not be able to displace chlorine. So what happens? There would be no reaction that would take place. Okay. So these are the things that we have to remember here because they would be asked in the exam as well. So now let's move towards group zero elements. Group zero elements. Okay. So group zero, or you can see group zero are basically noble gases. They are noble gases. What are those noble gases? Let's look at them. So they are basically, you can see these are the noble gases: helium, neon, argon, krypton, xenon, radon. Okay, let's write them as well. Helium, then we have neon, argon, krypton, and xenon. They are also called as monoatomic gases. Why they are called as monoatomic gases? Because they would not form any bond with any other element. The reason behind is that their outermost shell is complete. Outermost shell has 8 electrons. Shell has 8 electrons. So what happens if they are going to have 8 electrons, then they would not be able to form any bond with any other element. Okay, so they exist as monoatomic gas. So what is the definition of monoatomic gas? That they exist as single sorry, so they exist as single uncombined atom. Okay, they exist as single uncombined atom. What happens to this? Let's discuss some of their trends. That their boiling point increases downward, increases downwards. So the reason is, as the atomic mass increases downward, as atomic mass, as atomic mass increases downward. So what happens if atomic mass is increased downward, then force of attraction would also increase. Then force of attraction increases. Increases, okay? Now let's discuss about some of the more things. Let's discuss about their uses. So we have helium that is basically used in weather balloons. Okay, weather balloons that travel upwards. Then we have neon that is basically used in advertising lights. Then we have argon that is used as inert gas for electric bulbs. And then we have krypton that is used in electronic flash guns. And the last one is basically a radioactive gas. Okay. So now let's move towards transition metals. We have discussed that transition metals are the one. Okay. So transition metals, you can see in the periodic table as well, that these are transition metals that are present between group 2 and group 3. So they all belongs to the transition metals, okay? So they all basically belongs to the transition metals, okay? Now, what happens in transition metals? Let's look at here. That transition metals, they have some of the properties which are unique, okay, and they have some of the common properties. Unique properties are very important. Properties, first of all, let's discuss about unique properties. First of all, the unique property is that they form colored compounds. They form colored compounds. Colored compounds. Like, for example, the compound formed by copper, okay? Like, for example, we have copper sulfate. Their color is basically blue color, okay? And then we have the compound which is formed by iron plus 2. It shows green color. And the one which is shown by Fe plus 3, that shows the reddish brown color, okay? Or you can say they can form the reddish brown or yellow color. Okay. Okay. So this is the first unique property, and let me just complete with the unique properties here as well. The second unique property is, this is the first one. So the second one is that they can be used as a catalyst. They can be used as catalyst. Okay. Like, for example, we have iron, which is used as a catalyst in the manufacture of ammonia, which is used in manufacture of ammonia. Okay. Ammonia, ammonia gas. Okay. So third unique property is that uh, they have variable oxidation states. These transition elements, these have variable oxidation state. Okay. Like, for example, copper has the oxidation state of Cu plus 1 or Cu plus 2. So, the one which is iron would be having plus 2 or plus 3 as their oxidation states. Okay. So these are basically the properties of transition metals. So let's also discuss about their common properties, which are common properties, which are the characteristics of most metal, that they have high melting point and boiling point. Second thing, they have high density. And the third thing is that they are good conductor of electricity. Okay, so these are the properties that are associated with transition metals, and this is all about periodic table. Okay, so kindly please like my channel and subscribe it. Thank you so much for watching Chemistry with Shazia.